Hey, good morning. How's it going? It's Monday, May 16th. Just finished off of breakfast and just looking at the computer over here to see what's going on. There is a severe weather threat today, so this is the visible satellite. You can see there's clearing developing over here over the Texas Panhandle, Oklahoma Panhandle, and the clearing is shifting from west to east. We can see some bubbly cloud, which is convective remnants from the ongoing convection right now. I'm sitting in Elk City, which is right over here. Amarillo is over here, and what you can see on the surface map are the dew points are rising. I'll show you that a little bit better in a second. Looking at the surface analysis, we have our low sitting on the New Mexico-Colorado border. There's a warm front extending from that. Earlier in the morning, this warm front was sort of draped across here. Now it's lifted north. Still a lot of cloud cover, but there's tons of moisture. Stuff is moving in from Texas. This is going to be what's interesting because this is going to track that way, and we have a number of features to worry about. Number one, we have a dry line. Number two, we have the warm front. And number three, there will be a cold front extending back that way. Looking at the mesonet for Oklahoma, again, you can see dew point 61, 62, 60. 60 again, all extending. These are some of the highest dew points. You see they drop off into the 50s over here and throughout the rest of Oklahoma. But this bulge of dew points, which does extend into Texas, is moving northwest. So it's coming out of the southeast and moving northwest. And if we look at the actual dew point map, you can see where some of the more moist dew points are. Some of the ones over here, this is as a result of precipitation and the lay of the land with topography. This over here, further to the southwest, is actually from advection occurring. Now, here's the current map, or at least the, the 23 Zulu forecast map. What the HRR is doing is it's basically popping convection towards the Oklahoma Panhandle. So this is really extreme western Oklahoma near the North Texas border. There's some higher dew points in here. I'm not sure if this is legit or if this is just a feature from convective feedback or whatever. But the thing is, our dry line will be sitting over here approximately. There is a cold front extending back this way, and you can see that the warm front is going to be sitting like this, where the kink is over here in the isobars. Now, whether this will happen or not, as the model says, well, that's questionable, but we'll see. What is interesting is that this is the 4-kilometer NAM that I'm looking at, or the WRF NAM, and it's popping convection right on where there will be a triple point axis. And what's interesting is that the HRRR is doing the same thing. And if we look at the reflectivity, you're going to see something very similar. And again, see, it's very similar to the NAM where it's popping this. Now, what I'm curious about is the stuff further south, just north of Amarillo, these may actually be discrete storms on the dry line, and it's just not developing them. So this over here is the fly in the ointment, so to speak. We're going to try and see what this does, because this could put out a lot of outflow. This may also not necessarily be supercellular. It might just be a big mean cluster of storms that produces a ton of hail, but not much else, although we have yet to see. Bulk shear numbers to the whole region over here are good. Depending on where you are, supercell composite and significant tornado parameters vary, but they're all in here. So there's a risk. It's all just really dependent on what storms go up and where they are. But again, you can see there are similarities with the simulated reflectivity product between the HRRR and the WRF NAM. So we'll see what happens. It's not an easy setup. What the SPC is doing is they're seeing that convection here, and that convection is going to travel like this. So they're basically gridding out this whole area and saying, listen, if that cluster of storms does develop, it'll eventually begin blowing out, and it can be quite severe. There's a big wind hazard. Don't forget, this is severe weather overall, hail, high wind, and tornadoes, not just tornadoes. If we look at just the tornado risk, you can see that they've extended it, but it doesn't quite cover the enhanced risk. But the hail risk should extend much further, which it does. You can see the hail risk goes all the way across, but they have the highest hail risk, again, in that area with that cluster. The map keeps refreshing. Wind risk, roughly in the same area, and that's all because they expect it to blow out with possible embedded supercell segments to it. So it's a very complicated setup. Again, we're going to have to watch the surface maps closely and see what's going on here, because these will give us a good indication. And hopefully, what time is it now? It's It's 9 a.m. local time, so the balloon data should be in. So I'm going to go over a bit of that in the upper air data, and we'll see what's going to happen.